Welcome everybody to the 6th lecture of Informatik 1. In this lecture we will cover the first part of data analysis. So what is data analysis? If we stick to the definition by Wikipedia, then data analysis is a process of inspecting, cleansing, transforming and modeling data with the goal of discovering useful information, informing conclusion and supporting decision making. So let's look at each step in detail. If we perform data analysis, we usually follow a pipeline of steps. The first step in this pipeline is the data extraction. This step basically covers the process where you read the raw data into your program. And you can do this, for example, by connecting your program to a database and read the data from there. Or you can also read the data from files, which you have downloaded, for example, from the internet. Once we have read the raw data into our program, we can then continue with the next step in the pipeline. Once we have loaded the data, we can start with the inspection of the data. At this point, we typically deal with missing values in the data. For example, if we want to analyze gender differences in income and our data contains 100 entries of individuals containing their income and gender, where 2 of them did not specify their gender, we can, for example, remove those 2 entries with missing gender from our dataset. And similar, there could be, for example, 1 male billionaire in our dataset, which we could also remove. After cleaning up the data, we can continue with the next step in our pipeline. Data transformation. At this point, we can combine the cleaned data with other data from other sources. For example, if our income data also contains information about the job positions of the individuals, we could join the minimum income as defined in the collective agreement, zu Deutsch Kollektivvertrag, to our data. After that, we could perform calculations on the data. For example, we could calculate the difference of the individual's income to the minimum wage as defined in the collective agreement. After transforming the data into the desired shape and form and calculating our desired metrics, we can move on to the next step in the pipeline, which is the analysis. Here we typically start with a visualization of the data. For example, we could plot the average wage of men and women in each job position. And here we can then also apply some more advanced statistical analysis, which we will not cover in this course. The last step in the data analysis pipeline typically results in an action. Here you could apply statistical models to perform predictions on the data, or use such models to decide which further actions should be performed. For example, if you would analyze COVID-19 data, one could also use such analysis to support decisions made to reduce the spreading of the virus. Here you can see some useful libraries for this data analysis pipeline. And as you see, for the first 3 steps in the data analysis pipeline, namely for data extraction, data cleaning and data transformation, one can use, for example, the bundles library. And then for the data transformation and analysis step, one could also use, for example, the NumPy library. And then for plotting, one could use, for example, the matplotlib library. And for the analysis and the action part, one could also use the scikit-learn library, which includes advanced statistical models which are needed for machine learning, for example. And in this course, we will dive in a little bit into the bundles library, as well into the NumPy library, and also we will show you the matplotlib library. So let's start with the very first step in our data analysis pipeline, namely data extraction. As already said, CSV files or comma-separated values files are a common way to store data in general. And so, for example, if we have a table containing views of YouTube videos, which has 3 columns, namely the first column video, which just holds the name of the video, a second column called date, which holds the date when the video was uploaded, and the third column which holds the number of views which the video got. So if we want to store this table in a file, we can use the comma separated values format to do so. Here you can see the content of a file called youtube_data.csv, and this file basically contains all the data of the previous slide and some additional data. And yeah, that's basically how the file looks. And as you can see here in the first line of the file, or in the first row of the file, here you can see the columns of the table, namely video, date, and views. And this is also called the header of the CSV file, which basically describes the columns of the table. And as you can see, the columns are in this case separated by a semicolon, zu Deutsch ein Strichpunkt. And this is called the delimiter. The next row in the file, or the next line in the file, contains already data. This is equal to the first row in the table. So as you can see here, we also have those delimiters here, in this case the semicolon. And so the first part before the first semicolon represents the data which is in the first row in column 1. So this is equal to the string Informatik 1 session 1. And then after the first semicolon, you see the date, namely October 9th, 2020. And then after the second semicolon, you see the number of views for the first row in the table. And I would like to point out that you can basically use any character as a delimiter. So you often see, for example, also simple commas as a delimiter, or you also see tabs as delimiters. So you can basically choose any kind of delimiter as you want. And therefore it is up to you, if you read in the data, to first look at the data and see what delimiter is used inside the data. And then you can specify, for example, in the CSV reader or in any other library, which character you want to use as delimiter. Alright, let's look at some code. So in Python we have already some built-in modules to handle this. And in particular, there is the CSV module. It is already installed on your computer, since it is part of the standard library. And you can import it using the import statement by just typing import CSV. And then to open the CSV file, you just use, as you have already learned, the open function. And we do this using the with s handler. So we type with open followed by the file path as CSV file. So we just normally open the CSV file as we open any other file. And then inside the with block, we instantiate the reader object from our CSV module. So we instantiate a reader object. And the reader object in this case takes two parameters. The first parameter is the CSV file object. So this is the file handle to the object, to the file object, which we just opened. And the second parameter is the delimiter. And as we have seen previously, in our case, in this data, in this YouTube data, the delimiter character is a semicolon, and therefore we need to specify the semicolon as delimiter character. And we then store this csv.reader object in a variable called reader. And then we can just iterate through the rows in the file using a for loop, for example. So we just type for row in reader. And then we can, for example, print out each row in the CSV file. So let's look at it in our Jupyter notebook again. So here you can see I have prepared the same code as I have shown you on the slide. So we import our CSV module here, and then we open our CSV file, namely YouTube_data, using the with s notation, and we then store the file object in a variable called CSV_file, and then we instantiate a reader object and pass it the CSV file handle, and we also specify the delimiter, which is in this case the semicolon, and then we just iterate over each row inside the reader object and print out the row basically of the CS of each print out each row. So we can also look at our data first. So here you see the data, and as you can see, it assumes first that the delimiter is a simple comma, and therefore it cannot parse it correctly. So if we change here the delimiter to the semicolon, you see that it correctly parses all the columns. So as you can see, the first column is called video, the second date, and the third views. And yeah, it contains all the videos with the corresponding dates and the views of each video. And if we execute our code here, you see that it prints out basically all rows or all lines inside the CSV file. And as you can see here, the first row which got printed out is the header of the CSV file, or more specifically the column names of the table. In this case, video, date, and views. And as you can see here, since we have specified the correct delimiter, the CSV reader object automatically created a list of us where each element in the list is equal to each column. And then, as you can see here, the second row which got printed out is equal to the second line in the CSV file, which already contains the first data. In this case, again, the first element in this list is equal to the first row in the first column. So this is basically the title of the first video. And then the second element in the list is equal to the second column of our table, which is date. And the third element in the list is equal to the value of the third column in the first row of our data. Next up, I will briefly introduce the pandas library. The pandas library is a very powerful and flexible library for processing data. It simplifies the data cleaning and data preparation process a lot, and I mean really a lot. And it hides all the details and the complexity of the reading and writing process of data from the programmer, which means you do not need to do this manually. And it also integrates the NumPy library to enable easier calculations. And at this point, just a quick side note, if you may have asked yourself what is the difference between a module, a package, and the library in Python. So basically a module is just a file, a simple file or a single file which contains various Python functions and global variables, and that's it. The package is then a collection of modules. So it's a collection of files containing functions and global variables. And the library is then a collection of packages. That's it. Alright, let's look at the pandas package or library in detail. So here in the first line, we import the pandas package using the import statement again. And since this is an external package, you need to install it using a pip. How you can install this will be shown you during the tutor sessions. So for now, we just assume that you have pandas already installed on your computer. We can then just simply import it. And then we want to read the same CSV data as previously. However, this time we use the pandas package for that, or pandas library for that. And to do so, we state the name, which is pandas, followed by the dot, and then the function or method which we want to call. In this case, read underscore CSV, which in this case takes two parameters. The first one is the file path, or more specifically the path to the CSV file which we want to read, which is YouTube underscore data CSV, and also again the delimiter of the CSV file. And in this case, the delimiter is a semicolon. And we store the result in a variable called data. And this is again the first step in our data analysis pipeline, namely data extraction. So we can execute this line. And then the nice thing about pandas is that it has a really nice visualization of data. So if we print out this object here, it will print out already the content of the CSV file in such a nice table. And in contrast, if we print it out using the print function, you see that it's just a textual representation of that. But if we remove the print function and just basically type in the object itself without the print function, it will create such a nice visualization inside the Jupyter notebook. And at this point, I would like to mention that this only works in the Jupyter notebook. So this doesn't work in the console, for example. Alright, so this is basically how you can read it, or how you can read data from a CSV file. So it's just one line of code, and you have read the whole data. And then you can inspect the data, for example. So imagine that this CSV file not only contains 13 rows, but for example 5,000 rows. Then you don't want to print out the whole table as here. For example, you just want to print out a few rows in the beginning. And to do so, there is the head method, which just prints out the first few rows of the data. In this case, it prints out the first 5 rows. And yeah, so this is a very useful method to inspect the data. Then there's also the info method, which basically prints out information about the data inside. So for example, as you can see here, the data has in total 3 columns. The first one is the video. It contains 13 non-null objects, more specifically 13 strings. The second column is the date column. It also contains 13 non-null objects, and the last column is the views column, which contains 13 integer objects. Alright, so then we have also, for example, the describe method. The describe method basically gives you some statistics about the numerical columns or the numerical data in your CSV file. And in this case, the only numerical data is the views column, and therefore it returns some statistics about the views column here. So you can see, for example, the mean value for all the views in the data is 239. So on average, our videos got 239 views. Here you can see the minimum value, the maximum value, the median value, and so on. And the count represents the number of rows basically. All right, that's it for data inspection basically. Then using pandas you can also filter the data for data cleaning, for example. And in pandas, one very handy property or method is the lock property or method, and it is basically you can think of it as accessing the elements in there like in a matrix. So the first part here represents the rows which you want to index, and the second part here after the comma represents the columns which you want to filter out. And in this case I want to locate basically all rows where the views are greater than 200, and using the column I specify that I want all columns. So this is the same notation as in slicing. There the column also meant that we want all characters, for example. And therefore here if I specify the column, this means give me all the columns. So the first part here, this is the row indexer, so it specifies which rows I want, and the second part here specifies which columns I want. And if I print this out, it will give me all the rows where we have more than 200 views, and it will give me all columns. So for example, if I change the column here to the string video, it will give me only the video column and all the rows which obviously have more than 200 views. So if I print this out, you can see now we have only the video column. And I can also pass here a list, for example. So for example, if I want the video and the date column, I can do this using a list. So I specify a list as the second indexer here, and then it will return me a pandas data frame containing only the video column and the date column. Alright, so and if I print this out, this notation here, you will see that it will give me basically a list where each element in the list gives me a Boolean value of this comparison. So the first true value means that the first row, the data of the first row, which is 547 views, is greater than 200, and if this is the case, then the first element here will be true. And the second element represents the result of the second value in the second row and the comparison. So if the second value is greater than 200, then this will be also true. Alright, so and as you have already noticed, using the dot notation again, I can access the columns of this so-called data frame here. So by just typing dot views, I can access a single column. So we can print this out again, and as you can see, it prints out all the values for a single column, in this case the views column, and you also see here the type of the column, namely integer. And if we print out, for example, the type of such a column, you will see that it is basically a pandas object with the name series, and we also can do all type of mathematical operations on it. For example, we can calculate the sum of all these elements here using the sum method. So we specify the column followed by the operation what we want to perform on the column. So for example, we can calculate the sum of all these elements here to calculate the total number of views over all videos. And in this case, we got in total 3,114 views on all of our videos. And we can also, for example, then perform nice element-wise operations. So for example, if we want to calculate the fraction of views, we can just use the slash operator, which is equal to the division. So this is the division operator. So we can, for example, just calculate the fraction. As you can see here, the first video got 17% of all the views, the second video 13% of all the views, and so on. And as you can see here, we were able to perform this element-wise division without any loop. So we just wrote down, so this object here is a list. So you can see here, previously this is a list here, or a pandas series which holds several values. And the second element here is basically a single integer. And we divided each value inside the list by this single integer here without a loop. And the reason why this works without a loop is because in the background, pandas is using NumPy. So if we type views and values, we get all the values inside the column views. And as you can see here, it prints out the values inside an array. So if we, for example, print the type of those values here, you see that the type of the values inside a pandas data frame is a NumPy n-dimensional array. And therefore we can perform all those nice element-wise operations like division, multiplication, addition, and so on, because in the background pandas uses NumPy. Alright, and as a side note, in general, it is always good to read the documentation of a function, a method, or property if you use any external module, package, or library. So if you want, for example, to look up in more detail what this location function here does, or this locate method, you can look it up in the documentation of pandas and read up there what this function does. So this is always a good thing to do. And if you use any other external modules, the first thing what you should do is always read the documentation. Alright, so now you know that pandas is using the NumPy package in the background. So let's look in more detail what the NumPy package is. So NumPy is a fundamental package for scientific computing in Python. One can also say that it is basically MATLAB in Python. So it contains a powerful n-dimensional array object, and this is the main object of NumPy. It also has some sophisticated functions which you can apply on those n-dimensional arrays. and it implements also some very useful linear algebra like matrix and vector products. And last but not least, it also contains some powerful random number generation. So as already said, NumPy's main object is the multidimensional array. And in NumPy, dimensions are also called axes. So we can import the NumPy package using the import statement. And since we are computer scientists, we are lazy and we don't want to type NumPy each time we want to access some functionality inside this module. And therefore, we type import NumPy as np. And this way, we just need to type np every time we want to access functionality inside this package. So if we want, for example, define such an NumPy array, we just need to type np.array, and inside the parentheses we pass it a list containing 3 elements, namely 1, 2, 3, and this way we can define a NumPy array with one axis, and the axis contains 3 elements, and this is then equal to a vector, and therefore we store this NumPy array in a variable called vector. Similarly, we can also define a two-dimensional array, again by calling np.array, and then as a parameter we pass it a list of lists. So we pass it a list where each element in the list is again a list. So the first list contains again 3 elements, namely 1, 2, 3, and the second value in the list contains again a list with the values 4, 5, 6. And this way we have defined a two-dimensional array, which is also known as a matrix. And we can, for example, then print out the shape of the NumPy arrays using the .shape property, and in this case it returns a tuple which states that this NumPy array has 2 rows and 3 columns. And similarly, we can also, for example, print out the value of the ndim property, which stands for number of dimensions. And in this case, our matrix, which we have defined over there, has 2 dimensions. Therefore, it has, or one can also say, it has 2 columns, and each column has 3 values. So each dimension has 3 values. So as I have already told you, NumPy has some very powerful built-in functionalities in order to work with those NumPy arrays. So for example, all the standard operators are available in NumPy, and those operators perform element-wise. So what does this mean? So let's look at an example. So we can define a vector participants weight, for example, which holds the value of 4 participants, so namely the weight of 4 participants in kilograms. And we can define another vector, participants height, which holds the height in meters of the 4 participants. And then we can calculate the BMI for each participant by just writing participants weight divided by participants height squared. And since those NumPy operators are element-wise, we do not need to write a for loop or something like that, where we divide each individual element with the corresponding value. So instead, we just need to write the element-wise division here. Similarly, NumPy has some built-in universal functions. So for example, we can define again a vector which just holds some random numbers, namely 0, 1, 2. And then, for example, we can calculate the element-wise exponential using np.exp, or we can calculate the element-wise square root by using the .sqrt function, which just calculates the square root for each element inside the NumPy array. Or there is also the trigonometric sine, which is also, of course, as always, in NumPy element-wise. And here at this link, you can see a full list of available universal functions in NumPy. So since the NumPy array is a class, it implements some very handy methods. So for example, if we define again our vector, which holds the weight of 4 participants, we can calculate, for example, the mean weight using the mean method, or we can find out the maximum value inside the vector using the .max method. And similarly, we can, for example, print out the minimum value inside the array using the min function. And again, please see the documentation for the full list of available methods in the NumPy array. So let's look at the example again. So here you can see the previous code which I had on the slide. So first I import the NumPy package using the import statement, and since I don't want to write NumPy all the time, I just type as np, and using this notation I just need to write np instead of NumPy. Alright, so we define our vector and our matrix here. First, the vector only contains 3 elements, namely 1, 2, 3, and our matrix consists of 2 columns, 2 rows, and 3 columns with the values 1, 2, 3, 4, 5, and 6. So let's execute this. Then I just again print out the shape of the matrix, for example, which returns a tuple where the first value is equal to the number of rows, in this case 2 rows, and the next value is equal to the number of columns. In this case we have 3 columns, so to say, and the number of dimensions here, and this matrix is 2. And we have also the slicing available in NumPy. So for example, we can access the first element inside the vector using our standard slicing notation. So let's execute this first. So as you can see, using these square brackets, I can access using zero-based index the elements inside the vector. So by specifying a 0 here, I can access the first element in our vector here. And similarly, I can slice the vector using the column here. So if I neglect the second value here, it will give me all elements starting by the first one. So from the first element until the end. As you can see here, this will return the complete vector. And also I can specify step size. So if you remember, the third value here represents the step size, and in this case I specify that I only want every second element. Therefore the second element here in the middle gets neglected and only 1 and 3 gets printed out. And similarly, I can also reverse the vector using -1 as a step size. And in this case, it prints out 3, 2, 1. So this is standard slicing, as we already know it. And we can also access elements inside a matrix. So in this case, the first value inside the square brackets here before the comma represents the row which I want to index. In this case, I want to access the first row in the matrix, and again, using the colon operator, I say to Python that I want all columns. And similarly, I can use, for example, the colon in the row here, which says, okay, give me all rows, but only the first column. And in this way, I say, okay, give me the second row, since it is a zero-based index, give me the second row with all the columns. And in this way, I can tell Python to give me the first row and the first column. So this should be then a single integer. So let's look at the result. So as you can see here, using the first notation here, I specified that I want the first row using the zero-based index, the first row of our matrix here, and all the columns, as you can see here. And here I specified that I want all the rows, but only the first column, so 1 and 4. And here I want the first row and all columns, so the second row and all columns. So this is equal to this. And here I specified that I want the first row and the first column, and therefore it returns 1, as you can see here. Alright, then let's move on to our BMI example. So here I have defined two vectors which holds the weight and the height of 4 participants here. Here I have the kilograms of the 4 participants, and here I have the height of the participants in meters. And then I can just simply calculate the BMI of the participants by writing the weight divided by the height of the participants squared. And if I execute this and print out the result, you see that again the result is a vector which holds again 4 values since we have 4 participants, and the result is the element-wise calculation of this formula here. So first, the participant's height is squared element-wise, so it calculates the square of all those 4 values here, and then the result, so this is then divided by the result of this. Right. And yeah, we can also again call methods of the array, of the NumPy array, as shown in the slides. So we can, for example, again define our participants weight vector containing those 4 values here, and then we can access the class methods, for example mean, max, and min, which NumPy implements. And yeah, I think the name speaks for themselves. So mean just calculates the mean number for all the values which are inside the array. The max method returns the maximum value. The min method returns the minimum value. As you can see here, the average weight is 64, the maximum value is 75, and the minimum value is 50. And similarly, we can also, for example, store the data for men and women in separate rows. So for example, we can again define a variable participant weights, which in this case is now a matrix, and the first row in the matrix holds, for example, the weight of all men, and the second row here holds the weight for all women in our data. And similarly, we define a second matrix, participants height, where the first row is equal to the height of all men, and the second row is equal to the height of all women. And then we just print out, for example, the shape, and you can see it has the same shape, obviously, so 2 rows and 4 columns. And then, for example, we can calculate the overall mean again of the whole data, of the whole matrix. And in this case, the overall mean of all values inside this array here, this 2-dimensional array, is 62. And the overall mean height is 1.6 meters, for example. And then we can further, for example, and calculate the mean by gender. And we can do so by specifying an axis index. And in this case, we want to calculate the mean over the first axis. So we want to calculate the mean over the horizontal axis here. So we want to calculate the mean for all those numbers here and the mean for all those numbers here. Therefore, we can specify an axis which will then calculate the mean over the specified axis. And in this case, axis 1 means, okay, calculate the mean over the horizontal axis here. In this case, it will print out, so the first value here represents the mean for the first row, so to say, and the second value here represents the mean for the second row here. And similarly, the mean for the height got calculated. So if you, for example, change the axis to 0 here, this would calculate the mean over the vertical axis here, so the mean of those two, then the mean of those two, and then the mean of those two, yeah, and so on. And for a detailed explanation on how those NumPy axes work, you can follow this link. There you can find a very nice explanation how those axes work in NumPy. And similarly, we can also use our normal notation here as previously and calculate the BMI for all the values in the matrix. Alright, that's it for today's lecture. And as always, thank you for your attention and see you next time.